again, here we are talking about notes, proportional relationships and equations 2-4. Of course, we need to make sure we have your copy of notes out in front of you. In our box here, it says that you have used tables and graphs to represent proportional relationships. And now we're going to be discussing that an equation in the form of y equals mx can also describe a proportional relationship between two variables. And again, they have this sentence, recall that when there is a proportional relationship between x and y is a constant multiple of x. This constant multiple is the constant of proportionality. So what they have done for you is they have written y equals mx. But then they're saying m is the constant of proportionality, which is also our y divided by x, which we also talked about yesterday is a unit rate. So now we actually have 4 descriptions describing the same exact relationship, but using totally different explanations. M is the same thing as the constant proportionality, which is the same thing as y divided by x, which is our unit rate. It then says that since the value of y depends on the value of x, y is the dependent variable and x is the independent variable. I might have just said that backwards. Y is the dependent variable and x is the independent. Looking back at the y equals mx again, where they're getting m, if I was to divide by m on both sides of this equation, nope, let me rephrase that. If I was to divide by x, so sorry about that. I divide by x, I want you to notice that the x's would cancel out on the right side, and that leaves me with the y divided by x, which is another way to explain the constant proportionality, and it leaves m all by itself. So what I'd like you to do is just to go through these next 8 equations and just decide whether each equation shows a proportional relationship, right? Yes or no. Go ahead, do that, pause the video. And just go ahead and take a look at what your responses compare to mine. All the ones that say yes, I want you to notice just have one term being multiplied by the variable. The ones that say no have this little bit of extra here. So for example, this y equals 4x minus 5, that is a no because it has a little bit extra, and the y equals 6x plus 2 is also a no. Your coefficients can be negative, your coefficients can be fractions. It didn't say anything about that. It just has to be one number. Example number 1 is a complete example. So I'm really just going to leave this up here in case you guys want to refer back to this. It's really the same thing that we're going to be practicing in number 2. I like this example because it shows you the equation of y equals 8 and 5/10 x, and it calculates the total cost y in dollars for x movie tickets. They want to know what the constant proportionality is, so they are going and dividing by x right here, canceling out that x, and now we have the 8 and 5/10 equals y divided by x. So y divided by x was another way to explain constant proportionality, so they're telling us the constant proportionality is $8.50 per ticket. What does the constant proportionality represent then in this situation? The constant proportionality represents the unit cost or unit price, y, per movie ticket x. We can then use the equation that they gave us, y equals 8 and 5/10 x, to figure out how much will 13 movie tickets cost. If 13 movie tickets, if we look back to what our x and y represented, x was the movie tickets, so if you substitute 13 in place of x, and then multiply, you'll get that it costs $110.50 for 13 movie tickets. On example number 2, it says that the equation p equals 4s represents the perimeter p of a square with side length s. What is the constant of proportionality? What is the perimeter of a square with side length 1 6/10? The equation that they gave to us, I'm going to write down as p equals 4s. It is very similar to the equation y equals mx. Instead of having a variable where the 4 is, or where the m is, they have a 4, which that's not a big deal. So what we're going to do is we're going to solve for the 4. We're going to divide S on both sides, and we have now that P divided by S equals 4. And if we kind of think about, that's really the same thing as Y divided by X. So the constant of proportionality, the COP, is 4. We can then use the equation P equals 4S. If the side length is 1 6/10, I'm going to substitute 1 6/10 in place of the S. And 4 times 1 6/10 will give me 6 4/10, and it'll be meters. So that's the perimeter of a square. I'd like you to go on and try number 3 on your own first, because I'm just curious to see what you would do. So go ahead, flip the paper over, do number 3, pause the video. Okay, so going back to what we've talked about already, we talked about that Y divided by X is the same thing as our unit rate, which is also the same thing as our M. All 3 of these things are the same. So number 1, when they tell us a certain vegetable dip contains 60 calories per serving, they're giving you a unit rate right there. When they give us the unit rate, they're telling us that our M in Y equals MX will be 60. So that one I have a feeling most people probably got right. For the next one, if you were to just take the 60 and the 5 and try to figure out which one's going to work out there, you can't just use those numbers. You have to say, okay, oh, is there a typo here? I'm sorry, hold on. It's, yep. I put the wrong thing down, not 50, it should be 60. Yeah. Okay. So if we take 60 and divide it by 5, 60 calls divided by 5 hours, we now get our unit rate of 12 calls per hour. So Y equals 12X would be our equation. We're substituting the unit rate in place of the M. For the last one, again, 60 keys in 12 minutes is a rate. We're changing that to a unit rate by dividing, and we get 5 keys per minute. So now 5 is our constant of proportionality, our unit rate, our M, and so we substitute 5 in place of the M. Now that we've practiced that a little bit more, go on and try number 4. When I read this question, they weren't specific with telling me right in the sentence that $2.50 was the Y and 5 apples was the X. I got that from the N. So I just wrote the Y and the X above right here because it makes that easier for me to see. So I start by writing the Y equals MX and substitute the information I do have. So I put the $2.50 in place of the Y, the 5 in place of the X, and then notice that I needed to divide to get M by itself, and I get 50 cents. And this 50 cents is my unit rate. It's 50 cents per apple. Now, some of you probably didn't use Y equals MX. You probably just figured out what the unit rate was going to be and then substituted that in for your M. That's fine as well. The final answer should be what I have circled though. So now, when you travel to another country, you often need to exchange US dollars for the local currency. When you exchange money, you receive the equivalent amount in local currency based on the exchange rate. An exchange rate is an example of a constant of proportionality. So this exchange rate might not be completely up to date. This is recently the exchange rate for US dollars to Indian rupees was 1 US dollar equals 45 rupees. So the constant of proportionality is 45 rupees per dollar. How I think about this is if I give them 1 US dollar, I'll get 45 rupees. If I give them $2, I should get 90 rupees. If I give them $3, I should double that and get 45 times 3. So you can use the concept of proportionality here, constant of proportionality, to figure this out. So number 5 says you're going on a trip to Spain. When you ask for the exchange rate, your bank shows you the table. Write an equation you can use to find how many euros, Y, you will receive in exchange for X US dollars. So euros, they're telling me is my Y. And US dollars, they told me was my X. And having the X on the right and the Y on the Wow, I'm on fire today. X on the left and the Y on the right is consistent with what we've been practicing. So if we think about our formula or our little Y divided by X here, Y again represents the euros, X represents the US dollars. So you can really look at the relationship. This chart is showing you a proportional relationship. So you can look at the ratio between US dollars and euros for any one of these. I'm going to choose the one that says 175 just because they seem to be easy numbers to work with. So I'm going to put 75 euros in the numerator and 100 US dollars in the denominator. I'm going to divide that out to now get a unit rate of 75 hundredths euros per US dollar. So my unit rate, I now will say Y equals MX. Instead of putting M down though, I will put my unit rate in place of the M, and I get Y equals 75 hundredths X. When we now return from the trip, it says you have returned from your trip with euros left over. Use the table to write an equation you can use to find about how many US dollars Y you can receive in exchange for X euros. So now they've flipped the chart. They've now exchanged the Y and the X, and that's fine because when you go back into a country, now that you've come back from Spain, you want to get your money back. Okay, so this time we're setting up Y divided by X again, but we have to pay attention that Y, they said, was the US dollars, and that now X is our euros. So instead of putting 75 over 100, I have 100 over 75. When I divide this out and get my unit rate, I get 1 and 33 hundredths, and obviously it's a repeating decimal. So it's okay, since we're talking about money, to go to the nearest hundredths. When we write down our equation, it'll be 1 and 33 hundredths X. So we could just use this, that if, let's say, I had euros left over, since X is my euros, if I had 10 euros left over, I should be getting $13.30 US dollars. There's all sorts of equations and formulas that people use with exchange rates. Thanks for watching. We will see you tomorrow.